reprend avec notre guest speaker, René Rohner, chairman of the board of the Robot Framework Foundation, qui nous a fait le plaisir de venir participer à cet événement et de nous présenter donc Robot Framework, Keyword Driven Testing with Robot Framework and Playwright. Merci de l'applaudir et de
Yeah, thank you, Sebastian. Thank you for inviting me here to this nice testing evening. I want to actually, my talk is really fitting very well to what Sebastian explained about Robot Framework in the beginning, because it's actually giving some more practice to that topic. And I will demonstrate what keyword-driven testing is, what Robot Framework is, how it compares with Playwright, and give a little bit like an outview to what AI could bring us in the future as well in the Robot Framework ecosystem. So as Sebastian said, I'm chairman of the board. So Robot Framework is or the Robot Framework Foundation is an association, and we have a board there. Someone has to do the decisions, and so I'm part of that group doing the decisions within the year. It's an elected board, so the members elect this board. I'm also a consultant in Germany, working for a company called Imbus in Germany. We are specifically concentrated on the German market and doing purely software QA, so testing services with roughly 400 people. And I'm very specialized in the area of test automation, have a role so-called product owner of the value stream test automation. That means I'm trying to bring these 400, not the 400 people, but these test automation engineers within these 400 people on a table, try to develop a little bit like the automation strategy. And in that area, I also discovered Robot Framework some years ago, 10 years ago roughly, and I fell in love as Sebastian as well. So that's when I started like also preaching about Robot Framework, because we just think it's an awesome tool. And spoiler alert, it's completely open source, no strings attached. You can just use it for free. If you want to throw some money on the development, you can do, but I will tell something about that as well. So I will start with keyword-driven testing in the very beginning, because not everyone knows what that is. So what you see here on the right side is I would say the cat in the box with the two spaces that Sebastian was mentioning. So you see here we have keywords, there are spaces in the keywords, and then we have two or more spaces as a separator between the keywords and the arguments there. So keyword-driven testing is a test design methodology. So it's not a process like behavior-driven development or so. It's purely a way how you design your tests so that they stay maintainable, that you can have good handover between different people. And it's basically a descriptive keyword. So you write your keywords, your test commands in natural language. A keyword could also be called a step or an action or an interaction with your test object. It's human readable, as you see. There are very few special characters in there, no curly brackets, no semicolon and stuff like that, where many people start running away. So it's normal human readable, not only developer nerd readable. And it's easy to learn and understand. And keywords can be composite, so keywords can be made out of other keywords. It's basically procedural programming for testing. So there are some benefits or advantages of keyword-driven testing that are claimed and that I try to prove to you. So the one thing is it's modular by concept. So the idea that you can structure keywords within other keywords, you can create modules, you can create a tool set of keywords that you just use then in your test. And as further you get in your project, as more tools you develop yourself, and the reusability is increasing and increasing. At the same time, you have also the maintainability. If you have a keyword that, for example, fills a login dialog or executes a login, and it's called login user with a username and a password, for example, and your username is not anymore type username, type password, click login, but it's type username, click next, type password, click next, type in the one-time password, and then click login, for example, you can just maintain the one keyword and all your tests are running again, because we have these levels of abstraction in the test. It's basically clean code for testing, so I have clear abstraction levels, good wordings for that. And it's bridging the gap between the technical layer and the business. So because you can create these levels, so you have a click in the very bottom, then you have, for example, or a type text, then you have a type username, then you have an execute login, and then you have, I don't know, start hotel search as customer or something like this on the very top. This is understandable by the business people, and the click on a specific CSS selector is understandable by the technicians. And because you have all that in one framework, it's bridging this gap. And it improves readability because you have short and precise names. It encourages reusability because you create these functional keywords and you can use in multiple tests again. And as I said, the maintainability and also the flexibility, so you can exchange layers. The generic test automation architecture was also already introduced by Sebastian. Robot Framework is one tool that implements keyword-driven testing. There are other tools out in the market. In my opinion, this is the best tool for keyword-driven testing, and the benefit, it's open source, so it doesn't cost anything. So you have win-win situation. The thing on the right you also have seen by Sebastian, but he took the original one from the ISTQB syllabus. This is the one that contains basically the essential and needed stuff here. So concentrating on Robot Framework, which is basically the execution engine, it's a generic automation framework. It's not about front-end testing, it's not about back-end testing, it's technology agnostic. It can test or automate everything. It originated from test automation, acceptance test automation area, but nowadays it's also used in robotic process automation, where you have a business process with some software, and some software is not talking with another software. So at the moment, some humans have to, I don't know, read an email and get the information from the email, put it into SAP, and then from the SAP you get an export, and that export has to put in somewhere else or so. And because these tools are not talking with each other, you can use a tool like Robot Framework to actually bridge these gaps, these technology gaps between the tools, by using REST APIs, database accept, or even front ends. So for example, in Finland, we had the situation that the doctors, in the end of the day, have to fill in their patients they served in the front end of the insurance companies. And on this front end, it has no mechanical interface. So they had their software, they had all the data in the software, and in the end of the day, they had to take the data from here and copy paste it from one UI to another one. And I said, okay, come on, that's why, yeah? And we just automated that then with Robot Framework, so it's, in the end, they just push a button and it's then doing some UI automation to fill in these forms. As said, Robot Framework is fully open source, so seriously no strings attached. I'm here because Amadeus paid me to be here. Amadeus is paying me because they think it's a great tool. No one gets any money at that point. So also, there are some service providers about Robot Framework. If you need them, you can ask them, you may pay them, but you don't have to, absolutely nothing. It supports keyword-driven testing and behavior-driven testing. So you have also seen with Sebastian this given, when, then thing very briefly. So given I'm standing here on the page, when I give you a nice talk, then you should all be amazed and use Robot Framework tomorrow. So this is a Gherkin test, and Robot Framework supports that as well. It's completely technology independent. We have users who do front-end testing with web. We have users who do front-end testing with SAP. We have even embedded users. We have mobile testing users. For example, I know from AMS Osram, they are actually testing silicon wafers, so super deep down in the technology embedded stuff. We also have customers in the automotive, like Conti Automotive, they are testing EEPROM flashing. So it doesn't matter which technology you use. And it's financed by the Robot Framework Foundation, which is a non-profit organization in Finland. It's a registered association. And, oh, I have a wrong number there. We are at the moment actually more than 80 member companies in that association. And these member companies just throw a little bit of money in the bucket every year. And with that money, plus the income from the Robot Framework Conference, we finance the development of the tool. It was founded 2015, so 10 years ago, with 7 companies, and now we are, as said, more than 80. Here are some that you may know. For example, Fresenius or ABB, Cisco, Nokia still. So there are other big names, but they don't fit on the slides. So these are the download statistics of Robot Framework. As you see, the line that we are scratching there are 4 million. These are the monthly downloads of Robot Framework over time. We start there on the very left is 2016. Here, I joined the foundation, and then it rocketed up. I think it's just a coincidence, not an actual cause, but yeah. So Robot Framework is this central part. So Robot Framework actually executes the test and then calls whatever technology you have adapted to Robot Framework in the bottom. So these are the test cases that are written in Robot Framework, and if we take a closer look to these tests, we see the test is actually, for example, here we write a new test, we say, okay, open VS Dream Car, that is a car configurator, and then we start in VS Code, for example, with log E or so, we get code completion, so what are the keywords that are available? And one available keyword is the keyword login user that you see implemented right here. So here's the keyword login user, it has arguments, a username and a password, and that then calls again the keywords fill text, and click on some locators. Oh, I didn't need to zoom in, I think, here on this big screen. So when I now execute Robot Framework reads all these test files, which are in the folder structure, runs them actually, and then gives me readable results out of that. I can show this also in a live demonstration later. As adaptation technologies here, I will talk about Robot Framework Browser, which is a Playwright-based UI automation library, but you can seriously just like Google the technology that you need plus Robot Framework, and you have a very high probability that you find a library. May it be MQTT, may it be REST, whatever you like, RabbitMQ or so, and you will probably get a library here. Here are some others. RoboSapiens, for example, is for SAP testing, Postman, REST, Selenium, Appium, and so on. In these libraries, you then have actually code happening, some magic that actually interacts with your test object. And here you see the connection. So for example, we have this click keyword on the right side, which gets a selector. And on the left side, we see the implementation. It's a Python function that is also called click. It gets a selector. It has also other optional arguments, and that is then actually interacting with a test object. And like this, you can also implement your own functionalities. You have your own native API. There is no public library for the native API, so you can just implement it in whatever language you like. You can use Python. You can also use any other language to implement the actual test steps that are interacting with your system, and then use it in Robot Framework, maybe together with existing technologies like web front end and so on. Okay, and the keyword structure I already explained. As you see on the left top side, we have a high-level keyword, start car config as administrator. We are calling login user, which is implemented below, which is more, let's say this is a business logic, then this is a functional keyword. Then we have here type username, which calls type text to a specific element as a technology, and that is then implemented in Python. So this is the tickling down to the nerdy stuff. Okay. As I already said, this is one of the superpowers of Robot Framework, this possibility to nest these keywords. You get a collection of nerdy keywords, and from that nerdy keywords, you can then build up your own company keywords, your wording, French keywords, as ever you like. You can, by the way, also translate Robot Framework, also the Robot Framework own syntax, completely available in French. So you can have fully French tests for government testing or something like this. So some government agency, I heard, same here in France as in German, they stick to their own language. They don't want to read any English words. So we do the same stuff in Germany as well. So we deliver them a German Robot Framework. So if you search for Robot Framework on PyPy, you get over 700 libraries, ecosystem stuff that is made by the community for Robot Framework, actually. And based on that, you can just use it without writing a line of code, make your own keywords out of it, and just start. And that is a quick start that already Sebastian mentioned. When it comes to web testing, of course, because we are coming from a very generic approach, in the web testing community, we are not the big player as Robot Framework itself, because we can test everything, but we are not the superpower in web testing, but Playwright is. Playwright is the new rising star on the web automation sky. Playwright was released 2020. It's basically a fork of another library which was called Puppeteer. And it is an automation library that can test, these are the claims from Playwright on the left side, any browser, which is not really true, but it can test every Chromium-based browser, every Firefox and Safari, so WebKit-based browsers, which are basically every relevant one, now that Internet Explorer finally is dead. It's very resilient and has no flaky tests, in brackets, that are caused by the testing framework. If your shitty software that you're developing has flakiness, and sometimes it's working, sometimes not, the testing framework will find these flakiness and will show it. But what you will not have is you have a reliable software, and sometimes the test works and sometimes not. And that is some really benefits. So if you see flakiness, it's very probable that it's the actual test object that you have there. No trade-offs, no limits. This is a bashing of the competitor, because Cypress has on their website trade-offs, and then you see all the limitations that Cypress is not capable of doing. And all these limitations are easily handleable by Playwright. So you have basically no borders, no trade-offs. Fully isolated, fast execution, powerful tooling, I can sign that. This fork from Puppeteer, which was formerly developed by Google, suddenly all the developers showed up under a Microsoft account and released Playwright in 2020. So basically they just bought the headcount and said, okay, let's make a cross-browser testing thing, because Puppeteer was only for Chromium-based browsers. And Microsoft said, okay, screw them, we need a testing tool for our VS Code and our DevOps stuff and Microsoft tool chain. And we want to have cross-browser testing, so we just buy the people and they develop us this tool. That's why Microsoft came up with a Playwright. It's Node.js based. It has also some other implementations, but they all base on that Node.js implementation, actually. Okay. Here you see also the download statistics. So very on the left side, Playwright started during COVID, and then you see already here it's increasing, and it's definitely now far, far more used than any other tool in the Node or NPM ecosystem. So we in Robot Framework had already a big, successful web testing library, Selenium library. Everyone knows Selenium, everyone loves or hates it, but uses it. And so why inventing a new library? The one thing was Playwright, when we adopted it, already very early in 2020, it was way faster, way more reliable, and because it's directly connected to the browser, it also can directly communicate with the browsers over the Chrome DevTool protocol. So while Selenium is basically, it has an extension cord to the browser, so I'm on the other side of an API, then I'm phoning through this extension cord with a browser server, and that browser server then can communicate with the browser. It is a little bit like distance. You cannot get called by the browser. It's only a one-direction thing, so give me something, you get a response, but it's not a notification. There is a new thing, it's called WebDriver BiDi, which is a bidirectional communication, but all these problems Playwright didn't have in that time, so we could directly communicate with it. It's very open, it's also open source. It had an awesome implementation of Shadow DOM, so if you have web components in your software, go with Playwright. Forget everything else on the market, go with Playwright, or Robot Framework and Playwright, which I will come to that. We had nice selectors. We had a clear separation between different users, for example. We can use one browser, but have two contexts, so user one, user two, and I can test them separately and interact with each other. In Selenium, you always have to start a new browser then and shut down the browser and restart a new browser to have a new session. Here you can just spin up a new context, and spinning up a new context is a thing of a millisecond or a few, and you're switching between these two people. So that's really awesomely fast. And we as Python developers wanted to try out TypeScript, so it was also for us a curiosity, a new field, so we played around with TypeScript. And here you see two different tools. On the left side, you see the same test in Playwright, and on the right side, you see the same test in Robot Framework. For this, I have to say one thing, why I also like Playwright. Playwright is one of the rare tools on the market which is actually using a native programming language that has a concept of test steps. So if you use independently JUnit, anything else, you have a test class, you implement some stuff in the test class, but in the end you will just get a notification that test X was passed. You never get the information what the test actually did unless you implement your own logging steps. So okay, you do the login, then you log, I have logged in. Then you do some other stuff, then you log, I have done this thing. So actually having a test step, what has been done, what has been executed with which data is not by default given by these frameworks. Also in Cypress, you can create functions in Cypress, but it doesn't matter. So what's the end result? You get test results with a lot of click, 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 type, click, 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 type, click, 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 type, failure. And you think, oh, when did the failure happen? In which context? What was the actual function that I executed at that point? And then you start debugging your test because you have no clue what's actually executed. In Playwright, you have the possibility to actually write a function and declare that function to be a step. And then it really makes sense because then you have a tree of functional steps that calling technical steps and the functional one that fails. And you get more information out of it. So that's what I did here on the left side. Because it's TypeScript, because it's async, you have to add these await all the time. You have to write the class that is actually containing these test scripts here. You have to use these ugly brackets and semicolons. So 50% of your business users already have exited the door before you can lock it. And but on the other hand, okay, it's readable. It's doing the same stuff. So it's opening the VSR Dream car, then configuring a new car, select the base model, Model 3 rasant, then selecting a motor and so on. Same thing that happens here on the right side. Not more, not less. If I now go to the actual test steps that are implemented, you see on the left side this small add step decorator that you can implement in Playwright. And you see Playwright from the technology part is object-oriented. So you have a page. On the page, you get a locator with some specific selector. Then you have that element, this select base model element, and then you call the click function on that element. And this is a very typical pattern. Also, Selenium works, it uses that pattern for UI testing. You always go from the main page in some areas on an element, and then you call click or type or whatever. That causes that the readability is not that great because you basically always have to concentrate on the right end of your test to with what thing I'm doing what. So the fill username I'm doing on the username. Okay, and the fill with a variable password I'm doing there. And here I'm clicking on new car. On the other hand, on the robot framework, you see it's more as our brain works. I'm doing what with what. So I'm doing the actual action, the fill text on the username, I'm filling this username. So it's easier to read from left to right. You don't have to analyze so much. Also, if you have longer tests, you can, for example, just concentrate on the actions. So I'm filling text here, or I'm logging a user, configuring a new car, and then you can look to the data on the right side. These are the Playwright logs. So of course, this is what you typically have in every framework. If you have a failure, you get a stack trace. You get an information of what actually failed. For example, here the .check failed with test timeout 10 seconds exceeded. And you can also then scroll down to the actual test report. And that's the nice thing with Playwright. You get your high-level test steps here. So you get the select base model, not with the data, but you get actually the step. And then you see, okay, this get by label check for checkbox checking happened in my select accessories, 2 accessories were okay, and the third one failed in that case. I think, oh no, first we go error next, then the first one with the floor mats that passed, the not existing one by purpose failed. On the other hand, the robot framework logs look like this. If we zoom in, we first get a nice test statistic, so we know from the 4 tests that we have executed, 2 have passed, 2 have failed. It took 24 seconds to do that. Then you can drill down in these tree structure, and when we have a failing test, you also see like the OpenVSR dream car, login user, and so on, all these things. And you see also here, we have a click next, and we are iterating over a bunch of accessories. And here with the accessory not existing, we have the checkbox with that accessory, and then it failed with the same error as in Playwright. And we get already a screenshot here. I cut out the screenshot, we will come to that later, but you automatically get a screenshot of the failing situation here. And if you only look to the high-level parts, this is also, again, understandable by business users. So you don't have to expand it to this nerdy stuff. And you can understand the test, actually, and know where it's happened, where it's testing. Maybe not understanding why it's failing, but that's, for example, a thing where the AI works again. So you can actually feed that information, and we did proof of concept with that, and I think we will demonstrate this also next year on RoboCon, that we feed the AI this tree. So we basically feed the high-level steps until the steps where we are executing, then filling these failure, plus the Playwright failure, and explain the AI, okay, I'm using robot framework with Playwright, with this test object, explain this bug. And that's a point where the AI is pretty good in, because it can then explain why that happens or what happens, because sometimes you have some funky regex in the bottom there, and no business user would ever understand this failure. But here the AI can explain you, okay, this fails because that accessory not existing is not there on the web page. You can also see in the screenshot here it's not there, so it tried to select something that is not there, for example. So Playwright, and with that also Robot Framework has a really awesome tool. It's traces. I will also demonstrate that. Post-mortem, you can basically analyze your test. So you have a test, that test is failing on the CI. If you configure your system well, you can configure it so that you are actually re-executing the failing test, but the re-execution time, the second time you're executing it, with a very high log level. So you're logging basically everything. You're logging every network communication that is coming from the front end to the back end. You are logging every situation, the whole DOM. So you can basically post-mortem analyze this part here, which is not a screenshot, it's an actual snapshot of that web page at the moment of the failure. You can afterwards analyze which element were visible, what the selectors of these elements were, and you can completely offline basically fix your test if a selector is failing. So that leads me to a dream team of different tools, because as I said, Robot Framework is just this execution layer. You have to pick and choose your whole automation architecture. So you do not just get, I don't know, Runorex out of the box. This is your whole automation stack. You're using that one automation stack, that's it. You have no real possibilities to extend it. In Robot Framework, it's more like a best of breed of everything. Sebastian likes, I don't know why, VI. I would recommend Visual Studio Code. With Robot Code, which is the correct extension for Visual Studio Code, it has step debugging, it has code completion, it has everything every developer likes on his/her own IDE. And then we use Robot Framework, and at the bottom, as said, Robot Framework browser with Playwright. And at that point, if you're interested, I can do a short demonstration of how it looks like, how it feels. I think I have still some time, right? Good. You can also now, if you like, ask questions why I'm demonstrating this, if there are already some. Not yet. Okay. There is one.
Hello, thank you for excellent presentation. So I would like to ask, what is, from your point of view, things to improve in robot framework? What makes you wake up at night and think, okay, maybe we can do better? I'm sure you're sleeping very well.
I'm sleeping. I'm seriously sleeping very well. And if not, then it has nothing to do with robot framework, or I forgot something that is more in the management area than on the actual coding. There are many things that I still can dream of. For example, Sebastian explained about like parallelization. We have a parallelization tool for robot framework, which is called Pabot. But that could be optimized, completely rewritten, distributed over multiple computers, this stuff. So I'm really this guy of, that would be a cool feature, and then I'm not sleeping again, then I'm opening my laptop and I start coding. So there are some things, but unfortunately for I think the last 2 years I'm very, very short on time. So, but I would say it's a super mature tool, and yeah.
How about performance?
Performance is awesome. I can. So if
we compare with the Playwright,
you won't notice a big difference. There is a little bit, a little bit overhead regarding ramping up, but the Playwright test also has to be transpiled from TypeScript to JavaScript. So it's basically evening out, and during the actual execution, you won't recognize a real difference between the Playwright test execution and robot framework. There is nearly no overhead in the actual execution.
And automating complex scenarios also not an issue, right? Okay, thank you.
And we have huge test suites that are creating gigabytes of log files in the end, and they are working very well with thousands of tests. Yeah. Okay, so what we see here is
Hello, thank you for the presentation. And when we have a nested nested tests, will it be like synchronized, or can we customize, or?
So yeah, normally robot framework is executing in basically alphabetical order through the tree. So you start from the top. You can prefix it with numbers, for example, so that you get a different order. If you use Pabot for parallelization, you can actually define which tests are able to be executed in parallel, which has to be running in sync, or define some locking mechanisms. For example, if you say, I have, 2 different devices, and you can never use both devices in 2 different test scenarios or so, there is a locking mechanism in there. So it's a solved solution, a solved problem, I would say.
Thank you.
Okay, so what we see, here is a robot framework test, which is completely low level. And for example, if I write a new test case, wait a second, I will switch off Copilot because that's unfair. So I test case, and I do, for example, here, new browser, and it tells me, okay, I have Chromium and Firefox choiceable. Then I do, for example, here headless, no. And I go to a new page, and for example, framework.org, and then, for example, I do get title. And if I want to assign that get title, for example, to a variable, variables look a little bit ugly because they are actually using some special characters, because everything else is a string already. So that means variables needs to be escaped somehow. So variables using this typical $curly braces stuff. And then I can set a breakpoint here, and I can either run that test, which would then be pretty quick. So it's opening, and that's it. Closing basically again. Wait a second, I will do this here so that we see it actually directly. So yeah, if I run that test, it executes that test and gets the title and is done. I can also, as I said, set a breakpoint here. So if I press Alt or right-click and say debug test, and I have a breakpoint set there, it will stop at that situation. And now it's in the breakpoint, and now I can as in every other programming language, execute stuff. For example, highlight elements div, which then highlights all the divs in the page and so on. So if you have, of course, 2 monitors, you can put your screen there and do the debug console on another point. Let's go to this test is now, as I said, very atomic. And I could, for example, select that step and say, okay, extract the keywords. So this is start car config as admin. So it then has refactored and automatically created or extracted these functionalities to be a reusable test step. And I could, of course, use that in my next test case, or I could put it in a resource file and import this resource file. As you see also, you get a lot of documentation with all these keywords, so it's a normal developer experience, I would say. Here we have now 2 tests. I run this whole suite, and one of those tests is failing. So the first one is passing, it runs through it. Typically, the only delay that you actually experience is the test object that has some delay in it, except of that point where it waited 2 seconds and did not find that one element. You can, of course, extend this element finding timeout, but it says here the locator exceeded, the timeout exceeded to the locator, and when I check here, the leather wheel is not found, so that's the second argument here. And I can have a look to my actual test results. So I see here sorry, is it the right one? No, it's not the right one. Wait a second. This should now be verify price. That's a different suite. Sorry. Wait a second. The first one failed as well. Okay, got it. Yeah. Okay. Okay. Then let's analyze that one first. So the first one failed, and so the test step was verify price, and in that verify price we should verify the final price. So this one here with 28,000. Where was it here? Here, 28,873. But it actually verified that element at the top. So it highlights also the element that is verifying at the moment in case of a failure, and we see, okay, this thing here failed. So we can now analyze that test with my trace viewer. RF browser show trace, and I want to have this test here. No. Like this. So, and this is the trace viewer. So here I can completely go through my test. When I reload it, no. I can go through my test and I can see in the end there is something wrong. Oh, that was the wrong one, was it? That is the right one, sorry. Never do live coding on stage. That's always a messy situation. So I'm going here, and it now tells me that this price here at the top was the wrong one. So what I can now do, I can open my DevTools, and I can inspect that element which I want to have. This is this here. And I can see, for example, here, this is the actual locator. Label price sum. And I can fix the test by just going to that test. And here we have the wrong locator. So label price sum. And I go back to this one and re-executes the whole suite. And now it should give me another error. Oh, sorry. And then I'm nearly done. The second one will still fail, but the first one should now be fixed. So that will now fail because it cannot detect this actual element. And also here I could then inspect the element and fix that leather wheel. It's normally leather steering wheel. Something like this. Maybe it's actually with lowercase. Okay. Oh, and then I had a typo in there. Oh yeah, steering with double E. So that's a little bit of how it works. As said, you have code completion. I could also do a debugging at that point. So if I just run a test that fails, I will automatically have a debug point at the point where the unexpected exception is. So in that case here, if I'm running it on my computer, I directly have a breakpoint. I can directly see, okay, the checkbox with the leather steering wheel doesn't work. I can go to my browser, I can inspect it right at the point where it is, can even try out stuff. So for example, if I think I know, okay, that is not the right selector, but so leather steering wheel, if I try that, oh, and then I have to write it. Heiligt, yeah, that's if you know German, then you know why I spelled it wrong. So yeah, so it highlighted it. I could also call a keyword which is called record selector that would then automatically record it. So that's for the demonstration. I also want to show you the AI future for robot framework or some possibilities. I did not get really a word from the previous talks. So and the translator, the live translator was really bad with all these specific terms. So I gave up and went out. But I heard a lot of people were talking about MCP, Model Context Protocol, right? So we also have an MCP possibility in robot framework.
This is Mani.
And I want
Today I want to tell you about a powerful new tool that I developed. The tool is called RFMCP. What is it? Well, it's an MCP server for robot framework. What can it do for you? Well, nowadays you can connect MCP servers to a lot of tools, like coding AI agents. The MCP server will add robot framework capabilities to your agent. That means it can analyze scenarios in human language, afterwards recommend the best matching libraries, and then guess and execute steps stepwise.
So at the top,
so it will
input,
find the correct keywords, get the keyword
it.
documentation, and afterwards run your steps. At the end, it will create a final test suite for you. Now this final test suite is different to other test suites that are generated by agents, because this test suite will actually run. No hallucination, no guessing, it will actually run because each step was executed stepwise before. At the moment, the agent supports browser library, Selenium library, Appium, requests library, and the standard libraries. But more support will be added in the future. Well, give it a try and play around. Thanks a lot. Bye.
So this was Manika Siriha, the fellow robot framework community member who started with this MCP stuff. The request library, by the way, is a library for HTTP and REST testing based on Python requests. And the database library for any kind of SQL database is also supported nowadays with the MCP. And if you want, I can show you also the MCP in practice, that we can execute something, for example, like how to test that the dinner starts at 21, so at 9 p.m. at the Soirée. So, and that's basically it. Thank you very much for your patience and your attention.
So we have time for 1 or 2 questions only. If you can ask your question when you are on the top of the room, not at the end.
So what I actually told that one, use the MCP server and create a test and visit this site and go to the registration on the Sophia-Antipolis and check that the dinner starts at 21, and that's now what the AI is doing. Okay, now the question.
Thank you for the presentation. I would like, since you are able to run, I assume, robot keywords when you have the debug statements in the debug console?
In the console or in the AI now? What?
In the console before.
Yeah.
Is it possible / friendly to use robot in REPL mode? So I just open the console and I type my keywords.
That was one of the sleepless nights I had when I woke up and said, oh, damn, that would be cool to have a REPL mode in Robot Framework. So there's a tool, it's called Robot Framework-debug. And with that, you can just type iRobot and then start just Robot Framework in a REPL and do all this stuff with code completion and everything. I can show it in the break. Okay.
So the last one, if you want.
We can also do it in the break, so the next speaker
yes,
can come
perhaps
up.
During the break after you can ask your questions. Huh? So, thanks a lot, René.